All right, the second stage in the modeling process is the first floor. To begin modeling it, go to the floor plan view for that level and import the AutoCAD drawing that contains the elements we need to model. We'll repeat the same steps as before. Go to the Insert tab and select the Import CAD option. The file we need is called Blueprints Floor 1. Make sure the units are set to meters, the positioning is set to manual, center, and that it's being placed on level 1. Then click Open. Sometimes the imported plan appears far away from the model. In that case, just click somewhere in the view to place it. Once it's inserted, zoom out a bit and you should see the plan in the distance. Now simply select it and move it closer to the axis of your project. As we can see, this plan is already properly rotated, so all we need to do is move it into position. To do that, go to the 3D view and switch to the top view. Here, we can see that the corner of this column on the CAD plan should align with the same column already in the model. Use the arrow keys on your keyboard to nudge the CAD file until those two corners align. Once that's done, we now have the first floor plan in place, and we're ready to start modeling the elements for this stage. The first thing we're going to model on this floor is the columns. As you can see, the CAD plan doesn't include column dimensions. So what can we do? There are two options to determine the dimensions of the columns we need to model. The first option is the same approach we used for the foundation columns. Refer to the other blocks in the model that have already been completed. By checking those, we can see that the columns are of type 300 by 500. The second option is to open the AutoCAD file directly and measure the column dimensions there. Now that we know which columns we need, we can start modeling them. Go to the Structure tab, select the Column tool, and find the 300 by 500 type in the loaded families. Remember, if you place the column near a corner and press the spacebar, you can rotate it before placing it. Place the column and repeat the same process for the other columns on this plan. Now that I've finished modeling the rest of the columns, we can go to the 3D view to confirm that they were added to the model correctly. To wrap up the column modeling, the last thing we need to do is assign the 4D task ID value. If we look at the columns from the other blocks, we can see that all first floor columns have a 4D task ID of 91. So we select our columns and assign that value to the 4D task ID parameter. The next step is to model the slab for this floor. We'll also do this from the Level 1 floor plan view. If we were going to model the slab from scratch, we would go to the Structure tab, select the Floor tool, and use the available sketch tools to draw the outline of the slab. However, in this file, we already have a model that includes part of the slab from previous modules. So what we need to do is extend that slab to cover the area of this new module. To do that, it's easier to first go to the 3D view and switch to a bottom view. From there, we can select the slab that already exists across the other three modules of the block we're editing. With the slab selected, choose the Edit Boundary option, but make sure to do this while in the Level 1 floor plan, since that's where we can see the plan lines to guide the extension. In this view, you'll see pink lines outlining the current boundary of the slab. In this case, we're going to delete the line that currently closes off the sketch and extend the boundary lines to cover the full footprint of the new module. Now we can start sketching the new slab boundary. Select the Line tool and begin drawing the outline for the new portion. As a best practice, make sure to draw around the columns rather than through them. This prevents the slab from being modeled beneath the columns, which could result in inaccurate quantity takeoffs when calculating volumes or areas in Revit. By wrapping around the columns, we avoid that issue and can continue drawing the rest of the slab boundary following the red reference line that indicates the slab edge. Once you close the sketch, you can also draw around any interior columns, and Revit will interpret those outlines as voids or openings within the slab. Now, the slab sketch should be complete. To finish, click the green Finish button. And just like that, the slab should now extend continuously across the entire block. As we can see, the whole block now has a complete floor slab. Since we modified an existing element rather than creating a new one, the 4D task ID assigned to the slab remains intact with its original value. The next elements we need to model are the overhead beams that sit on top of these columns. To model them, go to the view named Roof Start Exposed Beam View. In this view, we'll insert the AutoCAD plan that includes the specifications for these beams. Go to the Insert tab, select Import CAD, and choose the file named Roof Blueprints Block A 2.75 meters. Make sure the units are set to meters, the positioning is set to manual, center, and confirm that the plan is being placed on the exposed beam level. Now repeat the same process as before. Rotate and move the imported plan to align it with the axes of your project. You can check the alignment by matching the corner of a column in the CAD plan with the same corner of the modeled column in your project. Once it's aligned, go back to the Roof Start Exposed Beam View, and now we're ready to model the overhead beams. Go to the Structure tab, select the Beam tool, and you'll see in the plan that the beams are specified as 0.3 by 0.5 meters. In your family list, find that beam type and begin modeling them from the center of one column to the center of the next. Switch to the 3D view to check how the beam was modeled. As we can see, the beam was placed at the exposed beam level between the two columns. However, we actually need the beam to be positioned on top of the columns. To fix this, select the beam and adjust the start and end offsets. Set both offsets to 0.5 meters. After applying the change, you'll see that the beam now sits correctly on top of the columns. Now go back to the exposed beam view and preferably delete the previously placed beam. With the correct modeling conditions in mind, place the beam again properly. Once you've finished modeling all the overhead beams, they should appear directly on top of their respective columns, with no gaps between beams and proper intersections where needed. When that's done, we can go ahead and assign the appropriate 4D task ID. In this case, according to our model, the value for overhead beams is 93, so select all the overhead beams and assign them the 4D task ID value of 93. Now we're going to model the walls of the first floor. To do this, we go to the Level 1 floor plan view and make sure the CAD file called Blueprints Floor 1 is already imported, since we'll use it as a reference for placing the elements. The walls will be positioned based on the red lines visible in the plan. These lines indicate exactly where the walls should go. It's important to note that we'll be using two different types of walls in this stage. We begin by going to the Structure tab and selecting the Wall tool. The first type of wall we'll use is the masonry wall, which will be used for all visible walls throughout the model. The second type of wall we'll use is the 150 millimeter thick wall. These are placed on the exterior edges of the module, and that's where the windows will eventually be installed, just like in the other modules already modeled. This is important because Windows in Revit must have a host, so this setup is necessary to make that possible. Back in the Level 1 view, we begin with the masonry walls. We go to the Wall tool again and select the masonry wall type. Before placing the wall, we need to check a few settings in the Properties panel. First, make sure the constraint is set to height and that the top constraint is set to the exposed beam level. This means the wall will be modeled starting from Level 1 and will extend up to the level of the exposed beams. Also, in the Location line setting, choose Core Face Exterior to ensure proper alignment and modeling behavior. Once those parameters are defined, we can begin placing the walls. When you click to place a wall, you may notice that the wall line doesn't align exactly with the red reference line from the CAD drawing. In that case, the best approach is to start placing the wall from a corner. At the corners, the wall lines will usually align perfectly with the plan. From there, we continue modeling along the indicated lines. If you encounter a situation where the wall makes a small jog or offset, you can press the spacebar to flip the face of the wall and adjust the direction in which you're modeling. In areas where the plan shows doors, you can model the wall continuously across the doorway. Like windows, doors in Revit also require a host. Once we place the door, Revit will automatically cut the opening and fit the door into that space. So, for now, just model the wall continuously through those sections. At this point, all the masonry walls should be placed. Now we just need to model the second type of wall, the 150 millimeter thick walls, which will be used for the areas where the windows will go later. We select that wall type and model those two segments accordingly. With that done, all the walls should now be in place. We can switch to the 3D view to visually confirm that everything looks correct and that the wall elements are in good condition. The last step for this part is to assign the correct value to the 4D task ID parameter. If we select one of the previously modeled walls, we can see that its 4D task ID is set to 105. So we select all of the masonry walls and assign them that same value. The concrete walls we just modeled won't receive a 4D task ID because they're placeholders for windows that we'll model later. To make this process easier, we can use the filter tool. After selecting everything, use the filter to isolate just the wall elements, and then assign the 4D task ID of 105. If the two concrete walls were included in the selection, you can manually deselect them and remove the parameter from those specific elements. And with that, the first floor walls are complete. To finish the modeling of the first floor, we're now going to model the floor finishes for two specific areas: the teacher's lounge, located in the outer section of the module, and the restroom floors within that same lounge. To begin, go to the Level 1 floor plan. Under the Structure tab, select the Floor tool. The floor type we'll use for the teacher's lounge is called Piso Sala Prof, and for the bathrooms, we'll use the tiled floor, named Piso Baldosa. Let's start with the floor for the teacher's lounge. We'll sketch it similarly to how we modeled the slab earlier. Select the line tool and begin drawing the sketch for this floor, following the outline of the module in this area. The sketch for the teacher's lounge floor should include two rectangular areas and cover the entire lounge, excluding the sections where the tile floor will go. Those tile areas will be placed separately. Since we're modeling this on level 1, and the slab was also created at this level, we need to apply a height offset to ensure the floor finish sits above the structural slab. We'll assign a 0.01 meter offset to achieve that. Once the sketch is complete, we click Finish, and the floor should now be added to the model. You can clearly see the sketched sections from the plan view, and in the 3D view, we can confirm that the finish has been placed on top of the slab as intended. Now we assign the 4D task ID to this element. For the teacher's lounge floor, the value is 127. Next, we return to the Level 1 plan and model the tiled floors for the restroom areas. Inside those rectangular spaces we left empty. Go back to the Structure tab, select the Floor tool again, choose the Piso Baldosa type, and model it within those empty areas. Just like before, we apply an offset of 0.01 meters so the floor finish appears correctly above the slab. Once the sketch is done, click Finish and check the result in the 3D view to confirm it has been modeled properly. Finally, we assign the 4D task ID to the tiled floors, which in this case is 124. With the floor finishes completed, we've now finished modeling all the elements for the first floor stage. We're ready to move on to the roof stage, which will begin in the next video.